So for number 6, okay, we have a 235 milliliter sample of gas collected over water at a temperature of 28 degrees Celsius and a low pressure day of 738 torr. Report what volume it would have at dry STP conditions. All right. So these 2 words are going to be important to us, but let's go ahead and write out what information we do have. Here, let me zoom in a little bit so you guys can see it. Okay. So, the 235 milliliter, let me say day 1 versus day 2, right? Because what we're comparing 2 different days here, okay? So we have 235 milliliter sample. So which thing is that taken care of? Which variable? Volume, good. Okay. And then we have over water at a temperature of 28 degrees Celsius. All right. Just because we're probably going to have to change it, what is that in Kelvin? Yes, it is. It's true. It's something 1. 301. There you go. Oh, yeah, no. Okay. Quick question. Can you guys see the pink okay?
No.
It's messing with my eyes, so I'm going to change it on the next one over. All right. And then finally, we have a low pressure day of 738 torr. So we've got information about pressure, but quick question. Is this the pressure that we want?
No, probably not.
Why? Who is it? I don't know. I think some of you guys are saying bits and pieces. So it's atmospheric pressure. What pressure do we want?
760 torr. That's 190.
Not yet. We're talking about a sample of gas. Is this the pressure of that sample of gas? No, that is atmospheric. So that's where we're going to use the stuff that we did at the very end of class yesterday. Okay? I was just trying to get you guys to see that first. If you don't see it yet, you'll see it in a second. All right, let's go to the day 2 information. So volume is what we are looking for. Temperature, you guys have already told me we're going to be relating it to that STP. So that is 273 Kelvin. And pressure for STP is what? Let's keep it in torr to keep it consistent. So 760. There we go. Good. Okay, so now what we're going to do is, if you were to look at this in general, what kind of question is this? Like, what kind of equation are we building? Combined gas laws. Is that what you just said? Yeah, okay, yeah, combined gas laws. Okay, and so in the end, we need to get it into combined, which is our PV over T equals PV over T. However, before we do that, okay, I kind of told you guys, this isn't the information that we necessarily want, okay? The important part is that it says it's collected over water. So what do we need to look at? The pressure chart thing. Good. All right, so that second packet that I just handed you, it's on the back. Flip it over and look at it. It's okay. I did it very sneakily. Okay. All right. So, it is 28 degrees Celsius. So, therefore, we've got what? 28.3. Good. Okay. So, remember, our equation yesterday was PATM was PH2O plus the gas. We want the gas information. So, we're going to go ahead and plug in 738 is equal to your 28.3 that you guys just got off your chart, plus that. Yes?
I'm just kidding.
Okay. Okay. So what is that pressure of the gas? True. 0.7, right?
709.7.
Okay, there you go. 709.7. All right, cool. So this right here, this is the pressure for that first bit of information. Okay, do we understand why we had to do that? Is everybody good on that? No. Okay, because it's collected over water. This information that they gave us is the pressure, the atmospheric pressure. Atmospheric pressure is not your sample of gas. Okay? The atmospheric pressure is like, you guys are in my room doing a lab, that's the pressure of the room. I want you to tell me the pressure of a certain amount, of a certain gas that you have in a container. Totally different, okay?
It's not just there to throw us off.
No, it's not there to just throw us off. Nope, it's actually important. So collected over water tells you that you need to have water vapor pressure. That's what you have to look up, okay? All right, the dry STP. What do you think is important about our word dry? Do you think it's collected over water?
No.
No, exactly. So do we have to do anything fancy with this little PATM, or I'm sorry, atmospheric is water plus pressure of gas. Do we have water vapor? No. So what we found out is your atmospheric is the pressure of the gas. Okay? So there you can use your 760. Okay? Are we all clear? All right, so you should know what to do from here. Start plugging in your variables. Just remember the 738 is not what you're using. You are using 709.7 for the first set. So go ahead and start plugging those in. It is not necessary.
And do we change it till we use? Okay, sorry. No, we don't.
No. All right, so what volume did you guys get?
99 milliliters.
I got 0.8.
Oh no.
I got 1, 2.
Oh.
I was all wrong. It'd be amazing.
I do give that nice.
It's like, guys,
199.03 milliliters. Okay, if you did not get that, please take a look at how, this is how I plugged it into my calculator. This is me doing the little crisscross thing that I talked about, okay? So I multiplied the 3 going this direction, and then I divided it by those temperature and pressure, okay? So just keeping your numbers straight on the combined gas law, I would say, is the biggest challenge on these, okay? So I'll give you a second, help your neighbor out, help yourself out, ask me questions, then we're going to move on. So you can flip it over whenever you're ready, I think, right? There's no more. Yeah, there is.
Oh, wait.
Yeah, there's one more page. Okay, all good? Sweet, awesome. All right, okay. So now what we're going to do is we're going to talk about mole fraction, okay? And mole fraction, I will tell you, last year, my kids freaked out about it because it just looks ugly. It's really actually super simple, and it's actually very useful because when you feel like you're stuck on a gas problem, sometimes you just have to use your mole fraction and then it all works itself out, okay? So don't be scared of your little mole fraction thing. Basically, the little top part is just telling you kind of where it's coming from, and it is coming from Dalton's law of partial pressure. So his little law was not just so we could collect stuff over water and just add a bunch of gases up to be total pressure. It wasn't that simple. He used it more so we could then relate pressures to moles, and you could figure out your different partial pressures. Okay, so when you have a big container filled with a mixture of gases, they each keep their identity, they each keep their own set of standards. They're just a mixture, and so each of them have a different pressure depending on the moles that are in there. Okay, we all clear on that? Mixture of 9 grams of oxygen, 18 grams of argon, 25 grams of carbon dioxide exert a pressure of 2.54 atm. What's the partial pressure of argon in the mixture? So do we hear what the big question is? What is the partial pressure of one of those three? Okay? All right. So you guys are just going to write down your little details, which was 9 grams of O2, because that's oxygen gas. It's diatomic, right? We have our 18 grams of argon. We have 25 grams of carbon dioxide. And then all together they exert a pressure of 2.54 atm. Okay, those are your details. So, in order to figure out how much this guy is exerting, we have that. Did you see where you would look at this and kind of feel a little stuck? Okay, so what does the word mole fraction tell you? You probably got to get it into moles. That's your first step, all right? So write your steps off on the side. The first step is you're going to make sure everything is in moles. Okay? Make sure everything is in moles. Then you're going to calculate mole fraction. By the way, I put FX, okay? So mole fraction of argon. And then finally, you're going to multiply it by the total pressure. Okay, so go ahead and start getting all those three numbers into moles. Mole fraction just means part over whole. Okay, part over whole. Once you get that fraction, you multiply it by your total pressure, and then you're done. Okay, so I'm going to do it silently up here. You guys work through it. If you need help, look up and just check your answers along the way. Okay? One of the big things, make sure you're doing O2, not just O. Yeah, at the end. Okay, what was your question? So basically, once you've converted everybody to moles, you add all your moles up, okay? And if you round it along the way, there's nothing wrong with that. I was just letting mine go until the very end. And then you would do part over whole. So I did argon's mole amount over the total moles in the container. And then that mole fraction I multiplied by the total of 2.54 to get 0.880 ATM. And then you're all done. So in my opinion, this is kind of really what you guys would be seeing is a question like this. But you're going to see that you're going to use kind of the same process in the next one that we're going to do. It's just a little bit easier. Okay? Do we have any questions over that? Are we less scared of mole fraction? It looks crazy, but it's not. Okay? So it's just a fraction. There's no units on any of your mole fractions either. Okay? So don't try to add units on there. Okay? All right. Cool. So moving up to the top of the page. Now we're going to knock out the easy ones. Okay? So that was considered hard. Here's the easy ones.
Crystal, would you like the iPad better? Like doing like hand.
All right, so the next one, number 7 at the top of your page says the mole fraction nitrogen in air is 0.7808. That was weird. All right, calculate the partial pressure of nitrogen in air when the atmospheric pressure is 760 torr. Okay, so what are we looking at there? Which formula off on the side do you think we're going to be using? They want to know what is the partial pressure. Yeah, exactly. We're going to be using this formula right here, which is actually what you guys did your very last step in the problem you just got done with doing. Okay? So all that this question did was it did the first two things. It took all your moles, it added them all up, it gave you your mole fraction. So you're starting at the mole fraction step, and we're going to go ahead and say your partial pressure of nitrogen is going to be your mole fraction. Whoops, it should be an X. Your mole fraction times your P total. Okay? So, looking here, I'm just going to say 0.7808, and we're going to multiply it by that 760 torr, and we should be getting it should be 593. That's it. 366. Huge difference, sorry. All right. Yes.
Can we convert the 764 to 1 atmospheric pressure?
Absolutely. And then it would just be in atmospheres. Yep. That would have been a lot easier, huh?
Wow, that's a great point.
Okay, but we're working on this. Okay. All right. There's another one where they're making you calculate the molar volume. And I'm like, ugh, don't write 22.4. Just calculate it. Never mind. You guys are just too smart. All right. Looking at the number 8. Okay. So partial pressure of oxygen is observed to be 156 torr with an atmospheric pressure of 743 torr. Calculate the mole fraction of O2 present. All right, so once again, look off to the side. Your different versions of this little equation, what are you going to be doing? Yeah, you're just going to be doing a little division. You're just going to put part over whole on your pressures. So hopefully what you're seeing here is your pressures are being related to your moles. Like it's very, very much together. Okay, so it's a ratio between pressures. Okay, so go ahead and do that one real quick. If you don't know what you're doing, just watch up here. 210. Okay. For 3 6. Okay? So just a little division, we're all good. Okay? You guys have any questions for me on that? Okay, when you get to the online homework is posted, so when you get to these questions, don't forget that you have that example at the bottom of your page, because that might be what they're really asking you guys for. Okay?
What does it do?
I think I said it Wednesday, but since PSAT thing stuff is Wednesday, it's probably going to be Thursday night. Okay? I just need to extend it one more day. Okay. Juniors, you're taking the PSAT, yes? Yeah. See, I don't want to stress y'all out. Okay. All right, cool. So we're moving on. Next packet. Whipping through this really quick, huh? And this whole first page should not be anything new for anyone. Congratulations, okay? Ideal gas law. Okay? It's your best friend. So this is where R starts playing a bigger role, okay? You have to use the constant. Please remember, and even if you have the blue one on your desk today, you have all the constants, I believe, on the inside, inside. They're on the inside. Just kidding. I couldn't find it. They're on the back.
Inside.
They're on the inside, just like with the yellow ones, okay? So you have your 3 R values on here. You have them in here. What is the big thing we have to pay attention to? The pressure, exactly, okay? Now, if you are solving for pressure, like we probably are in this first one, do we care which R we use? No, as long as your answer reflects which R you use. So pressure units are the only thing that really make a huge difference in this R. The other thing that is going to matter now is being in liters, okay? Liters and Kelvin are a must when you're using your ideal gas law, okay? Okay, are we all clear on that?
Yes.
All good, sweet. Okay, so PV equals nRT. Let's look at our first problem. What pressure is required to confine 0.460 moles of an ideal gas at 33 degrees Celsius and a volume of 9.5 liters? All right, so what's the first thing that stands out to you? Celsius. All right, so let's take care of that. $310. No. Yep. I did the same thing. Okay, 306. Cool. So we are solving for pressure, so we're just going to write out our nice little ideal gas law right there. Okay, since we're solving for this guy, we're going to move the volume over. Just like that. Okay, and now we're just going to plug in. Okay, so N is 0.460 moles. All times the R. All right, so do we care which R we use? No, I'm going to use the one that's given to me at the top of the page, though, because I feel like it. Plus, it's the one that puts it in ATM. And 306, all divided by 9.5. So I think 3 sig figs, whenever you've got it. 1.22 ATM. All right. Okay, easy enough? Told ya. This isn't going to be bad. You guys will be good. All right, number 10. Number 10 says determine what volume of 1 mole of a gas at STP would occupy. What is the answer? Yeah, okay. All right, so still do it. Just get your practice in real quick, okay? So use your STP. You guys are going to work through this one while I hand out your lab page, okay? So work through this one. Make sure you're getting 22.5.